All right, so we're doing the other side of this improper integrals. Let me just review what we did last time. I know you just did a quiz on it, but let me just review it. So we did if one of your boundaries was infinity or negative infinity. So you're finding the area under the graph like forever in each direction, which is cool. You can find a finite area when it goes on infinitely, which is cool. All right, here's the ones that we're doing today. And I drew little pictures for them. I'll take a picture of this and put it on Schoology so you'll have it. This is if you have a vertical asymptote in the graph. So this one says if you're continuous from A to B, and you have an infinite discontinuity, so a vertical asymptote at B, you just set it up with a limit going to that value. That's all that is. And I mean, if you want to draw that, you can. Again, I'm going to take a picture of this. This is just to give you a visual. This is what it looks like if you have the vertical asymptote at A. And again, you just set up a limit going to A. Now you're supposed to put from the left or from the right. It actually won't make a difference in your answer, but we should be picky about our notation at this level. So look, do you see how B is over here? Your limit would approach B from which side? Like you're going at B from the left, you'd have a little negative there. And for A, you're going from the right, you'd have a little positive there. Both of those are okay. This is the one that's the tough one because you have to notice it. It's not like real obvious in the problem. This is if one of your boundaries has the vertical asymptote. This is if that graph happens to have a vertical asymptote somewhere in between. So you just really need to be on your toes. And this you would set it up as a part A and a part B problem. And remember we did one last time where it was two of them, it was broken, it was really redundant, wrote the same thing twice. Well, that's how that turns out. So you have like a problem for each side of it. And again, if it doesn't work out, then it diverges. We're just going to practice a few of these. I have like 6 examples here. We're just going to try some. All right. So if you want to label, if you want to title, this is more improper integrals. And so again, the ones we did last time had infinity or negative infinity as the boundaries. These ones have vertical asymptotes in them, but they're all under the like umbrella category of improper integrals. And these ones are tough because you just have to be a good noticer. So notice if you were to plug 0 into this, do you see how you would have a 0 denominator? There's a vertical asymptote in the graph at 0. So if you like envision from 0 to 5, 0 has a vertical asymptote here. All right, so we're going to set it up with a limit. And again, I stick with A if it's the lower boundary and B if it's the upper boundary. Technically, you can use any letter of the alphabet you want. But this would be limit as A goes to 0. And then would it be from the left or from the right? Well, if here's 0 and here's 5, we would come at 0 from the right. So it'd be limit as A goes to 0 from the right. And then you would have integral A to 5 of the exact same thing. So the first step is exactly like what we did before. You basically just moving the problem somewhere else. Like if the problem was that there was a 0 there, we just turned it into a limit. And then you're going to do the antiderivative. So how can we rewrite this? I usually just write it off to the side. This would be x to the negative 1/2. If you can do that in your head, that's cool. I just always kind of like write a little note to myself. So you would add 1 to the power. So negative 1/2 plus 1 be 1/2. And then out front, you would put the 2, the reciprocal of that. And then such that A to 5. So we fixed the boundary, we made it a limit, we did the antiderivative, then what? It's the same steps as last time, so I didn't write the steps again. What do we do after that? Good, put your parentheses, upper minus lower. So if you plug in 5 to the 1/2, I would write that as a square root, that'd be square root of 5. So 2 square root of 5 minus, and then you're just plugging in A, so 2 square root of A. And then what's your last step, like the thing to finish it all off? Yeah, evaluate the limit. So limit is A goes to 0. Well, this first part doesn't have an A in it, so that's just 2 square root of 5. As A goes to 0, this goes to 0. And so your answer is just 2 square root of 5. Now, disclaimer here. If you didn't realize that there was a vertical asymptote at 0, and you did not write this limit and you did the problem anyway, you would still get the same answer. And if it was a multiple choice question, no one would know and you'd still get the right answer and it would all be fine. But if it's free response and you don't write a limit, they're not going to give it to you. So, but you will still get the same answer anyway. You look like you're going to ask something. Yeah, so this is x to the -1/2. It's negative because it's in the denominator and it's a half because it's a square root. So you add 1 to the power to raise it. So -1/2 plus 1 would be a +1/2. And then we always put the reciprocal out front. I think you're more used to seeing ones that would be like a 1/4 x to the 4th or a 1/5 x to the 5th. You know what I'm talking about? But this was to the 1/2. And if you reciprocate a half, you would get 2. All right, let's try another one. Oh, whoops, I'm already writing the limit. I want you to do that. Let me write the problem. So really similar. We're just going to practice the same steps. Twix is my favorite. Oh, there isn't. But whenever my son goes Halloweening, trick-or-treating, whatever, I always tell him, like, when he like reaches in, I'm like, grab the Twix because mommy wants this. All right, so what you have to notice is, do you see how if you plugged in 0 here, you'd have a 0 denominator? There's a vertical asymptote at 0. So technically you're supposed to write this with a limit. So, and I use A for the lower one and B for the upper one. So it's going to be limit as A goes to 0 from the right. And then what would you change your boundaries to? Yeah, A to 5. And again, you're just moving the problem somewhere else. All the rest of this is the same. And once again, if you didn't realize this and you forgot and you did the problem just regularly anyway without a limit, you would still get the same answer. But if it's free response, they're not going to give it to you if you don't write a limit. So, all right, then your antiderivative. So I would write off to the side. This would be x to the -4th. You have to add 1 to that. So it'll become -3. And then what do you put in front? -1/3. That kind of got squished all together there. You would rewrite that as -1 over what? Yeah, 3x to the 3rd. Good. Such that A to 5. All right, and then it's going to be upper boundary minus lower boundary. So let's see if we plug in 5. 5 cubed, do we know that one? 125, you have to triple that. So 125 and 125 would be 250. And then 375, so -1 over 375. And then for your lower boundary, just, you know, recopy it, but you're putting an A in there. And then your last step is to evaluate the limit. Now, this first part would just be -1 over 375, but what's going to happen with this one? You have a 0 denominator. So what do we put for this answer? Because you can't divide by 0. Diverges. When you go to evaluate that, you can't have a 0 denominator. Womp womp. So if you tried what? Right, like, well, even like I keep saying, these problems, if you forget to write a limit, like it's still gonna work. So where's the issue now? Yeah, B. Okay, so I would do limit as B goes to 0. Now you should put from the left or from the right. So if this goes from -1 to 0, -1 to 0, you're approaching 0 from the left side. And then it would be integral -1 to b. All the rest of this stays the same. So how can I rewrite this off to the side? It would be x to the -1/3. It's hard because it's a fraction and it's negative. Fractions and negatives are the most commonly missed thing, and that's a -1/3, so it's tough. All right. So when you go to do that antiderivative, you add 1 to the power. So -1/3 plus 1. Good. X to the 2/3. And so out front, you would put 3/2. Perfect. Such that -1 to b. This is really just a ton of notation. Like what you're actually doing, like there's not very much math. It's just like knowing what all the symbols mean. All right, then it's upper boundary minus lower boundary. Oh, why did I put a 1 there? That should just be a little negative. I'm sorry. All right, upper boundary minus lower boundary. So just plug in b. Let's rewrite that though, because to the 2/3 power does like bother people. And when you go to actually plug in a number, you want to know what's what. This 3 means it's a cube root. And this 2 means that what goes underneath the cube root? It's x squared. I like to bring that up because when you square something, it will turn positive, and that's about ready to be a conversation we're going to have like when we go to plug in the -1. Okay. Oh, sorry, we're supposed to be plugging in b. I need to get it together, Beth. Jeez. All right, so b squared. Because now we're going to plug in -1. So if you were to plug in -1, -1 squared would be 1, +1, cube root of 1 is just 1, times 3/2 would be 3/2. And then your last step is evaluate the limit. So if you plug in 0, like do limit as b goes to 0, this whole part goes to 0 minus 3/2. Okay, so what does that mean that we got a negative area? It means the graph is below sea level. Don't write sea level on your exam. Okay. Right off the bat, what's your antiderivative of 1 over x? It's going to be an ln. Okay. If you plug in 0 to this, you get a 0 denominator. So there's a vertical asymptote at 0. So that's why we have to write it as a limit. Limit as b goes to 0 from the left. So again, -2 to 0, you would approach 0 from the left side. Integral -2 to b, all the rest of this is the same. You're essentially just moving the problem somewhere else. You're turning it into a limit. All right, and then your antiderivative is ln, like we just said. And then upper boundary minus lower boundary. So that would be ln of b minus ln. So with the absolute value, like when you plug in -2, it's going to be +2. Following me there? And then last thing is to evaluate the limit. Do we remember what ln looks like? Because I feel like if you think about it from a graphing standpoint, yeah, like this thing, okay? So it's going to look like this. This is your ln graph. Just like in 2 seconds, you can have a picture of it. If you look at what goes on at 0, here's 0. Where's that graph headed? So what's our answer? Diverges. I'm glad we talked about that though, because in a multiple choice situation, they would probably put -infinity as one of the answers and diverges as one of the answers. You don't get an answer. Yeah, if you end up with like an answer of infinity or -infinity or something like that, it's going to be diverges. Like you can't have, because what we're finding is an area under the graph, and you can't have an infinite area. Like that's not an answer. It's basically like our version of no solution. You didn't get an answer. right, I'll only make you do one more. I don't like that example. Wait. This is not the boundaries I wanted to use on that. What did I want to do? -1 to 1. Sorry, I was changing my mind about what I wanted to do, like while you guys were doing the quiz, because I didn't like there aren't real great examples of these, if you know what I mean. They're not like real great problems. So I was kind of like changing my mind at the last minute with what I wanted to do. All right, so this is one of those ones that's actually really tricky. You have to notice that this goes from -1 to 1 and that 0 is in between that. And if you plug in 0, there's a vertical asymptote following it. Okay, so this is going to be like the two parts of the problem. So we're going to have to split it. It'll be -1 to 0, same thing. And then plus, and then what's the other one? Yeah, 0 to 1. You're going to do a little bit of writing for this one. Okay, just as a heads up. I promise you will get through it. It'll be okay. So now this problem is exactly like what we were just doing on the other side of the paper. All right, it would be limit. And since it's the upper boundary that's the issue, I would use b. So limit as b goes to 0. Ooh, from which side? We're going from -1 to 0. So 0 from the left. Good. Integral -1 to b. All the rest of that's the same. Plus limit what? What would you do for the second one? Yeah, a goes to 0 from the right, integral a to 1, good, 1 over x squared dx. You can do it, I promise. All right, now the antiderivative. How would you write this off to the side? It would be x to the -2. You would add 1 to the power, so it would become -1, and then you divide by -1, so -1x to the -1. Good, perfect. That was the next thing I was going to ask. -1 over x such that -1 to b. And then this one's going to be the exact same thing, except with a. So limit a goes to 0 from the right, -1 over x such that a to 1. Again, it's just don't do a copy error is basically what it is. Just a lot of notation. All right, what step are we on now? We did the antiderivative. Good, upper boundary minus lower boundary. I should have left more space. This is going to take more room. All right, so when you plug in b, that's just going to be -1 over b. If you plug in -1, it'll just be 1. Plus, limit as a goes to 0 from the right, upper boundary minus lower boundary. Oh, I'm barely going to make it fit. So if you plug in 1, you would get -1, and if you plug in a, it'll just be -1 over a. I'm going to write down one more thing after we put this answer. So copy it down with me because this is like the big takeaway and why I kind of changed my mind and I did this problem instead. Now you're going to evaluate the limit. If you go to make this b go to 0, it does not exist. So, well, you don't write d any, but we're going to put diverges. Humor me for a second. Call this 5a. Call this 5, write this, or 5b, I guess. The first one will be 5a. Call this 5b. I'm going to do one more example. Write down the exact same problem. The exact same problem. Pretend you didn't realize there was a vertical asymptote at 0. Pretend you just didn't realize that, and you were going to do the problem as normal. Pretend you didn't notice, all right? This would give you same antiderivative such that -1 to 1. Say you didn't know this. And you didn't do all that stuff with the limits and you didn't fix the boundaries. You just did the antiderivative and then you did upper boundary minus lower boundary. What would you get? -1 minus 1, which would be, I had to think about it for a second, -2. Is that the right answer? No, it diverges. So you have to be super careful, because if you don't notice that there's an issue somewhere in the middle of the interval, then you will get the wrong answer. And you had better believe that if it is multiple choice, they will make that one of the other answers, like 100% guaranteed. But these ones, like where it's just one of the boundaries is the issue, those ones usually will work out anyway. So you can kind of like get through that anyway.